Good day, Professor Breaker here with New Mexico State University. In this video, we're going to be going through the topics covered in Chapter 4 of the Python Crash Course textbook that we're using. This is for the ICT 362 course. One thing I wanted to talk about right away was a discussion response. Basically, we had the discussion for the welcome to class, and basically people gave their opinions and feelings about coding. And multiple students expressed that coding was difficult to grasp and enjoy, especially when they're just coding to submit an assignment. And I totally agree. Just coding for the sake of coding is not very fun. However, this course is meant to be a mix of learning coding and project-based coding, so hopefully you'll embrace the projects and try to, not only just do the projects, but go one step above and beyond. I actually took a programming course where the instructor said, if you do everything I tell you to do, you get a B. If you do above and beyond it, show it to me, I'll give you an A. Well, we're not doing that here, but it's probably a good idea because it's when you go above and beyond that you're actually going to do and learn the most from projects. I've been involved in several successful projects, and I tell you, the projects that I really learned the most from are the ones that I basically fell into bed at 3 or 4 in the morning because I was coding and I was just in the zone and coding and working on it, and made some really, really cool things. So to me, coding is like building. You can learn about the tools, but until you actually start building something and seeing the results of the code and getting it to do what you want it to do, that's when it's fun, and that's when you also learn the tools and their limitations. All right, so the topics covered in Chapter 4 of the Python Programming Crash Course is basically using the list structure. We got introduced to list in last chapter, in Chapter 3. In Chapter 4, we're going to be using looping through list using the for statement. We're going to look at Python code formatting, proper indentation. We're going to look at enumeration and ranges. We're going to look at comprehension statements. We're going to manipulate lists. We're basically doing slicing, copying. We're going to talk about tuples and a little bit about code style. So let's go ahead and get started. Terms, loop. Basically, it's a code that executes a set of instructions until a condition is met. We're going to be using the for loop. There's also a while loop. And again, the while loop is looking for a true statement. In the for loop, typically you're giving it some enumerated or limited set of data structures, or a data structure with a limited set of elements. And you're saying for each element in the loop, do something. Whether it's print it, change it, sort it, whatever. So the indent is basically in Python, we are using indenting to show where the beginning and the end of our for loops or our statements are, okay? In Java or in C, I believe you use in Java you use the curly brackets. Curly brackets, everything in a for statement, basically you'd create your for statement, you'd give your condition, and then you'd create a curly bracket, and everything inside that curly bracket was going to be related to that for statement. And if you had a nested for statement, you could have another for statement inside the curly brackets, but the curly brackets basically control your code. In Python, we're using indentation to control the code. So aligning your indentation to where the set of instructions is supposed to run is really important. Okay, comprehensions. Basically, it's combining multiple code actions into one code statement. There's a ton of these you can do with Python. I've learned some, but boy, there's a ton more you can do. We're going to just talk about it a little bit, and as we get working, we'll probably get exposed to more of those. The term immutable. Basically, it's an object that cannot be changed once it's created. Strings are immutable. You create a string, you can't just replace one character in the string. You can replace the whole string, but you can't replace one part of the object, one part of the string. A tuple is basically an object. It's like a list, but again, the elements cannot be changed. A slice is we're extracting a defined subset from the list. And you'll see us doing this in the code as we move on here. All right, so let's take a look at the for list. Looping through a list. So we've got the simple list, items, soccer ball, French horn. And we can do, I've got 3 different for statements. So let's go ahead and pull our code up here. I'm actually using VS Code here to display it. I've expanded it, so hopefully it's clear for you. But here's our items in our list. We've got the soccer ball, French horn. I just basically grabbed everything I could think of that would be in a garage. Torque wrench and soccer ball, yeah, those don't go together. but neither does a French horn. But I just grabbed everything you could find in the corner of a garage, and I threw it as a list. And so out of this list, I've got all these items, and I can do the for loop. And so if we look at this first for loop, I'm using a range, okay? I'm using the range statement. I'm saying for I, which is an integer, in the range, and I'm going from 0 to the length of the items. Now, if you remember from the last video, we talked about the length of the item is always one more than the last enumerator. Since it starts at 0, our enumerators are 0, 1, 2, 3, 4, 5, 6. So our length of our items should be 7. And the range statement goes from the first number given to one less than the last number given. So in this case, the last number given would be 7, or the length would be 7. So this is going to go from 0 to 6. So I is going to take the number 1, then the number 2, then the number 3. And we can print it out that way. We should see it this way. I should be 1, and then it'll be the items and their enumerator, or their index number. And I think the book uses the term index number. But so it's going to be the number and the index number. It's going to print those out. So let's go ahead. I'm going to delete these so we can see it clearly. And let's clear this here. Okay. So let's run this and see what the output is of this. And we'll see that we have the enumerator 0, 1, 2, 3, 4, 5, 6, along with the referenced item in the list, or the value of the element in the list. So for I is in range 0 through 6, or through 7, which is the one less than 7. We can print out the items. Okay, so that's using the enumerator. Let's go up here, Control Z. Now let's grab the next. I'm going to delete this one for now, and delete this one, so we can just look at these one at a time. So this is the easy, simple for statement. The simple for statement basically says, for item in items, print the item. Okay, now you notice we're creating a new variable. This is plural, this is singular. I could say for, R, for R in items, print R. Okay, because what we're doing is we're creating a new variable. It's easier for most people when they look at items and items. So if you create a list, oftentimes you'll make it plural because it's more than one typically. And then you can say for single item in items list, print item. But it doesn't have to be that way. This could be anything, and then we're going to print that variable. This creates a new variable, and it gets recreated every single time you go through the for loop. So if we were going to print this, again, let's clear this up. If we're going to print this, we can run this, and it'll just print the items. The thing is, it's not printing the enumerator. It's not printing any numbers associated with it. It's just giving us our items. And if we wanted to print them sorted, we could do the sorted. Actually, we can't do sorted because it'd be a single item. It wouldn't change it at all. We'd have to sort the whole items list. So we can just print that item. Okay, so let's use this last one. And this one is if you look at them, I'm going to have you compare these first. Actually, let's go one more. Compare all three of these. Okay, so this last one is kind of a combination of the simple one. We're just adding two things to it. One, remember we can do two variables. We can take two values and assign them to two variables. So in this case, instead of creating just one variable, we're creating two variables. We're creating a variable I, which is like the iterator, and again, it wouldn't have to be I. You could say for K. Let's put K for K, and then we would print out K here. So it's different from the previous one here. For K and item, we're creating two new variables, and the enumerate. Again, here this is nice. It tells you what the sequence is. Enumerate an iterable object. So these are iterable objects. And so you're saying enumerate items, and then we can print K and dash in the item. Okay. Now I'm using a different print statement. We used a format statement here. I'm using concatenation, and if you're going to concatenate, it has to be a string with a string. And since this is an integer, we have to cast it as a string. Yes, you can cast, just like you do in Java. You can cast variables, and so we're casting it as a string. Let's go ahead and delete these two, and just run this one. Let's clear this. And let's go ahead and run this, and you can see that we've got the same thing as what we had in the very first one. We're printing K becomes the enumerator, which starts with 0 through 6, and the item is the actual item. It's kind of like the simple for statement, only we're not adding a bracket 1, bracket, or no, bracket enumerator. We're just saying the item, because again, we're creating item as a new variable along with K, and it's printing it out the same. So we get the same thing. So there's two kind of things. There's one thing we can do with a numerator. With the enumerate function, we can say comma 1. And that means start with 1. So if I run this again, now it's numbering it 1 through 7. Okay? So the enumerator isn't specifically tied to the index number. It's just saying enumerate it. Just like when we did the previous one, and we said, hey, let's do the, does it keep it? No, it didn't keep it. Okay. When we did the previous one, saying just for item in items, do this, print it out, it does the same thing, only this one allows us to assign numbers to it. So it's not quite the same. Let's go back and look at all of these here. And let's go edit forward. Okay, so we did change that to K. So if we look at all of these, we can use the index number and refer to it as the index number as we print it out. And here we're just printing out the index number, so we have a number. We can go through it and print it out by the index number, picking the range of index numbers. Now, if we didn't want to print all of them, let's say we wanted to print the last 3, we could length items -3. So if we just wanted to print the last 3, and this might be a case where you're writing a program and it's thousands of, but you only want the last 50 items. So then your range could be, you've got this length of items, you got 1,000, but you only want the last 50. So you'd go, length items -3. So let's go the length -3. So now if we run this part here, you can see that we've got only 3 of them, 4, 5, and 6. So we're getting the last 3. So again, if you had the 1,000 items, you could get the last 50 or something like that. In this one here, this is the simplest, obviously. For item in items, print item. This is the simplest abbreviated for loop you can get. And this is an expansion on the abbreviated one. We're still using the 4 can items in enumerate items. And again, with this one, we can add 1 to it or change the numerator. It's not relying on the index number, because again, we're not throwing the index number in here. We're still just relying on the items, but we're adding numbers to them, and we can say, well, start with 1 when you add a number, when you're counting them. So the enumerate basically counts it. All right? So those are some 3 different things we can look at when we're looking at lists. All right, and that's what's shown here on looping through a list. Now let's talk about inside and outside the for loop. So let's go back and look here on our code here. We have let's go to the second one here, talk about indentation. So I've got this for loop for color and colors. It's really simple, and let's go ahead and clear this down here. And let's go ahead and run this. And you can see that that's not what we wanted. So we've got, it's printing color, and then it's printing my favorite color is red, and then this should not be indented. Because it is indented, it's printing every single time. Now, if we really didn't want it printing every time, we'd have to move it out in line with the for statement. So let's go ahead and run this again, and you'll see that we'll get, everything will print. And now, because these 2 are indented, these are going to be printed in the for statement, and this one is not. What if I remove this one? Move that out, again, in line with the for statement, and run it. Now we're getting all the colors, and then my favorite color is red, and this should not be indented. So moving the indentation. What about the number of spaces you indent? Okay, so now it was 1, I indented it 2. Is it still going to work? Yeah, it's going to still work. It doesn't care. What if I indent this one 1? Let's go and indent this line here. And is this going to work? No, it doesn't like it. Wait a minute. I'm looking at Again, indentation has to line up. If you want it inside the for loop, it has to line with everything else inside the for loop. That would work. But if it's not, and look, there's 1, 2, 3. So we're looking at 3. What odd numbers? We can do any, so long as they all align. Python doesn't care, but it has to align. Now, what if I did another for loop? Let's do this here. Let's throw another for loop in here. For we shouldn't use char. We should use for C in color print C. Okay, so tell me what's going to happen here. This is called the nested for loop. Now I've got my for loop, and everything inside of that for loop is going to be part of the for loop. So it's going to, these statements inside of the for loop are all going to work during that for loop. Okay, but I've thrown another for loop in here with another indentation. What's going to happen? Let's go ahead and run this and see. And you can see red. My favorite color is red, brown. It's doing the whole word, one letter at a time. And so you're seeing this for C in color. It's basically enumerating the color. And the first color is red, so it's going, okay, I'm going to enumerate the color red. So it's R-E-D. And I'm enumerating the color brown, B-R-O-W-N. And I'm going to enumerate and pull out in each element in the color orange. And so it's going to print every letter in orange. So it's enumerating those. So I've got this is called the nested for loop. I may want to say, I want this just to print once. Okay, so let's go ahead and run it again. And you can see down here, now we're getting the words, every word is getting redone. So here we go, here was the end of it here. Red, brown, orange, gold line. And so what we've done is we've created a nested for loop. But again, the indentation matters. What if I said, well, I want this for loop right there? Okay. And I'll keep my indenting the same, run this, it's going to say, no, you can't do that. It's in the for loop or it's out of the for loop. It either has to line up with the beginning or it has to line up with the other statements inside the for loop. Now, in this one I've got 3 spaces indented, in this one I've got 1 space is indented. Do all the indentations have to be the same? Guess what? No, it doesn't. Just because we did 3 here doesn't mean we have to do 3 for the inside one. But everything we want inside this one has to be the same. Okay, so if I'm going to do another print here, it has to be indented the same to be in this for loop. Otherwise, I've got to kick it out to the previous for loop or kick it out to the end. Because right now in this code, there is only 2 indentations. One is inside of this for loop, and the other one's inside of this for loop. Now, if I remove this for loop, now there can only be 1 indentation inside of the for loop. What if I say, hey, I can just indent anywhere, right? Let's go to the bottom one here. I can just indent this anywhere, right? This should work, right? No, it's not going to work. What's causing this to be indented? This has to be inside of another operator. The for loop, an if statement, it has to be inside something else. You can't just indent randomly. So again, alignment is key for this, and indentation basically tells what's in and what's out of the for loops or if statements or anything else like that. All right, so let's go look at the range function. We used the range function a little bit, I showed you that, but range function is real simple. It's just a way to create and generate a bunch of numbers. Okay, so let's look at the range function. Nums equals range 1 through 20. I'm just passing it numbers. And then for every number in nums, print, and if we just run this, let's go ahead and clean this up here. Just delete that so we can see it one at a time. If we go ahead and run that, you can see that I've created numbers 1 through 20. Now you notice I put 1 instead of 0. I could go 0, and it would be 0 through 20. Okay, let's run that. Now it's going to start at 0. You can see the first time I started it at 1. This time I started at 0. And you notice that on the range function, it stops at 19. Again, the range function goes from the first number to the number less than the last number. So if you put 20 there, it goes from 0 through 19. If I put 1 there, it still goes from 1 to 19. Okay? You look here, it started at 1 and went from 1 to 19. So that's how the range function works. It's just a way to generate numbers. Okay? Okay, so let's go ahead and look at what else we can do with the range function. Not only will print numbers just, let's go ahead and delete that too. Let's clear this up. Not only will it print numbers through a range, you can actually set what you want to increment it at. So in this case, we're going to print by 2s. We're starting at 1. We're going 1, 3, 5, all the way through 19. Again, if we start at 0, it'd be 0, 2, 0, 2, 4, 6, 8, 10, you know, the usual ones we're used to counting by 2s with. Okay, so the range function, very simple, multiple values you can pass to it. The most important are the first two, the beginning and the one that it's going to be the upper end of your range. Okay. Last, we can actually use these the consolidated statement, and we can do for I, we're going to print I for I in range, and let's see what happens with this. Okay, so here we're creating a range 1 through 10, and then for I in 1 through 10, we're going to print I. Okay, for I in range 1 through 10, print I. And that's what we're doing here. We're actually creating this, and it's all done within the brackets. You can see the brackets here, so it's actually printing it within the brackets. Basically, we're creating a list of numbers and printing it out at the same time. All right, and let's talk about it in the chapter. Some other things we can do with number lists. So let's go ahead, and I'm going to import random just simply because it's, to me, this is more fun than what they did in the book. So if I pull so much of random numbers, and basically I'm doing this range of 40 through 100. So this creates, 40 all the way through 99. So I have this range of numbers from 40 to 99. I'm going to give me a sample of 10 of them, 10 numbers in this range. That's my sampling. And I'm going to have just 10 random numbers between that range. Okay, so then I have those numbers. I could actually, let's print this out once. And then we can print use functions that are tied to the ranges or to our this creates a list of numbers. So we can use functions that are tied to a list and get the minimum, the maximum, the sum, and this way we could get average. So let's go ahead and run this. And you can say, here's our list of numbers. These are random numbers generated through this random. So we've got all these random numbers generated. So we've got a list of numbers. Now, I'm generating them randomly. You might be pulling these numbers in from data points. You've got a little Arduino board. You're collecting data points for temperatures over the last 60 hours. Or like, for instance, you take one of the latest things is keeping track of environmental conditions for produce. So I create a little device using an Arduino board that's checking temperature, humidity, and the geographic point. Your geolocation. And so you've got this tied into this board, and it's tracking this crate of fresh vegetables. And every 10 minutes, it's sending temperature, humidity, geolocation. It's doing a push up to a website. You're pulling that information. Now you need to analyze this information. You've been doing this every day, so at 10 minutes every day, that's 6 an hour. That's times 24. This gives you 144 data points. So you want to know the minimum data point. You don't want to know the maximum data point. You want to know the average of the data points. And so there you go. So you can use them in. You've got this list of numbers. This is your temperatures over the last, 10 temperatures over the last day. Your minimum temperature was 44, went from 44 to 95 degrees, and total was 708. The average temperature was 70.8 degrees. Okay, so there's one use of that, and you can use this quite often. Things like that are done quite often in analyzing data. So there's your number list, there's our average. We can use that with number list. Now, if we say, what if I have a different type of list? Again, this is the list of numbers. I'm creating a list of numbers, and I'm using code to generate it instead of creating my own. I have this list of numbers. What if we use colors? Can we do min, max, and sum? Well, we can do min. What would be the minimum color here? How would you determine what is going to be min? What is going to be max? Let's go ahead and run this. And you can see that in the colors, we've got the minimum is blue, the maximum is yellow, and then you can't get a sum of colors because they're strings. But how does it come up with minimum blue and maximum yellow? And it's really using what's called the ASCII table, ASCII. It basically has out of 255, because every binary byte is up 0 through 255. It's basically associating a letter with that. It looks at the first letter. If there's two of them with the same, if we had, we got red, I've got brown and blue. So looked at blue and looked at brown. Well, BL is before BR, so it shows blue. So use that ASCII characters, the ASCII numbers, numerical numbers of these characters, and came up with the minimum and maximum. And obviously, it starts with the first letter. So blue would be the min, yellow would be the max, because Y is the last one in the alphabet and the highest number on the ASCII table. So you can use some of these, but you can't use some. So again, with numbers, again, with lists, it has functions that will work with numbers, functions that won't. If you're pulling information in that could be string or data, you're going to have to pay attention to this. Okay, the book also talks about, we already talked about the functions with lists and numbers. Reference by reference and by value. That's how I've always heard it. They just did the copying variables. They talked about copying variables. I've always heard it, you copy by reference or you copy by value. And so they did this simple one here. Let's take it right to here and say, let's just stop it here. Let's go and delete that and clear this. I'm going to run this, and we're going to see that with the output here, we've got A equals, and we're creating a range of numbers, a list with a range of numbers, and we're printing it out, and say B equals A. Okay, so if B equals A, you would expect it to be the same range of numbers. That makes sense. If B equals A, it should be a list with the same group of numbers. Okay, so then we're appending 10 to A, and you think, okay, well, A is going to be, 1 through 10, and B is going to be 1 through 9 yet. But then when we go and print, we can say that A equals 1 through 10 after the append, and B equals 1 through 10 after the append. We didn't append to B. We just appended to A. How did B get turned into 10? And the answer is because when you said B equals A, you have to understand that when you created A equals this, you created a list object, and you stored it in memory. And A is the pointer to that object in memory. And then when you said B equals A, you said B equals the pointer to that object in memory. So these are equal. All right? B and A, they're not really the values, they're the pointer to the memory location that has this data set. Okay? And that's copying by reference. A is a reference to the data set. You're copying B equals A, so now B is a reference to that data set. It's very similar to like a soft link in Linux. When you're creating a soft link in Linux, you're not creating a new file. Actually, it's like creating a hard link in Linux. You can have multiple files tied into the same data or piece of file object. Okay. So if you just append it, it basically B is going to, because it's pointing at the same data set. Every time you change the data set, they're still going to point to the same thing. Okay, so now if we go and say, well, I'm going to change it so that B equals, and you could say, A through was, again, by default, this is 0 through the end of A, whatever A is. So if A is 10 characters, would we say it was 10? 1, 2, 3. So it's 9 characters. So we'd go 10. B equals A 0 through 10. You're taking a slice. This is called a slice because you could say B equals 1 through 3. Okay? Or 0 through 3. And then it would have 3 items, 0, 1, and 2. So let's go ahead and run this and see what that looks like. You can see that B equals only the first 3 of them. Now I don't have to put a 0 here. If I just leave that blank, it assumes 0. And we get the same thing, 0 through 3. And if I said I want starting with number 3 and going to the end, okay, I want a slice of A starting at the 4th, or the 1, 2, 3, 4th object to the end of the object. I could do that. And you could see it starts with 4 through 10. Okay, so if B equals a slice of A, 3 through the end of the object, we're getting all the way from 3 to the end of the object starting, again, this is here. But we just say we want all of A, all of the objects in A. Now this is different than this. Instead of B equals A, the pointer, B equals the pointer, they're going to be the same, they're pointing to the same data store. Now we're saying B equals all of the values in A. We're taking a slice of A, we're taking all the values, but the slice is actually all of the values, and B equals all of the values in A. And this is normally the way you'd slice it. You saw me slicing it here, the first 3, the last 6, or last 7. This is the way you'd slice it, but you can say all of them, refer to all of them. And then you say 8 out of append 11, so we append 11 to it, but B is still going to be the values of A. So let's run this, and you see that B is taking all of the values of A before it appends. This is, again, before it appends, you're assigning all of the values to B. So now you're creating a second data set, okay, out on the in the memory. And so A is pointing to one data set, B is pointing to a different data set. And when you change A, B stays the same. So again, by reference, B equals A. B equals all of the values in A. This is by value, copying by value. Okay, so this is 2 ways to copy. One's by reference, one's by value. Let's talk about tuples. Let's go into tuples. Let's clear this down here. And we can say that tuples are like a list, very much like a list. Okay, I'm going to remove this here so we can just work with the tuples. So I've got this simple little tuple here. I can actually remove this too. Give this tuple colors equals red, brown, orange, yellow. So it looks actually the same as the color list we had before. And if I print it out for color and colors, the tuple looks exactly like a list. You won't see any difference other than I made a mistake and somewhere's here. The name colors, oh, tube colors, there we go. Oops, Control Z. Let's get this back out here. For colors and tube colors. There we go. Okay, so for color and tube colors, so we're just basically printing out same as a list. This is a tuple for color and tube colors, print the color. We're just printing it all out. If we wanted to use the enumerator, we could do that. So if we did for K comma, K comma colors and enumerate tube colors and print, let's do the F. K okay, so we should be able to print the colors, formatted colors, and again we're getting the numeration and the colors. So we can just print the colors out, or we can print it's same as a list, same as we did with a list. We just enumerated and did them. Now, if we want to do slicing of colors, we can do that. Let's go ahead and look at this here. So we can print a slice of the tuple, okay? And again, we're using the references. So if we wanted to reference just one of the tuples, we could print It'll be the same as if we were printing a slice, or same as what we would do with the list. Colors, and let's pick number 4. So we're picking an individual object in the colors. So if we printed that, we'd say, I have a little error. I have to go to 2 colors. So if we printed this, we would get, yeah. So we would get our 2 color 4 is 0, 1, 2, 3, 4 is yellow, so we're printing out 4. Same as we've done with the list. We can pick a slice of them, printing from 1 to 5, which is going to be what? Actually, with the index number 1 through the index number 4. So it's going to be 1 starts with 0, 1 is brown, 2, 3, 4. So it should be brown through yellow. Is that what we have? Brown, orange, gold, yellow. Yes. So 1 through 4. Printing them sorted. Yeah, we can sort them too. Remember? Sorted does not change our variable. But now, if I want to append something, what happens? Now with the list, you can append, you can add to the list. Now this is going to give us an error, an object error. It's saying, no, this is a tuple object. It's not a list object. You can't append to a list to a tuple object. Okay, so we're getting an error. So let's remove that. But what if I want to? Is this going to change? This is completely, if a tuple object is unchangeable, what's this going to do? Is this going to work? Let's find out. Yeah, it's going to work. You're not changing any value in the object, or you're not changing, replacing one of the values, or adding to the tuple. The tuple is set, but now you're just reassigning, you're recreating the tuple from scratch. Basically, you're throwing this out, and you can do that. You just can't add or change it. So it really makes it a very limited, basically a read-only list. So lists are read and write. You can change values, you can add to them, you can pop things out of them, you can do all kinds of things with lists, but you can't change the list. Very similar to, let's do that, and similar to a string. A string is immutable. We know this does not work. But a string is immutable, just like a tuple is immutable, and they're very similar. So here's a string. You've got this. A string is also immutable. Print the temp string 1 through 5. So we're going to grab, this is 0, 1, 2, 3, 4, 5. So we should have a space and stri, actually through 4. So a space and stri. You can sort the temporary string, and you can do, but try doing an append on it. What you're going to get? You're going to get an error. Okay, you can't append, you can't change a string. You can reassign it, a new value to the string, but you can't change the existing string with append, or there's no functions that allow you to do that. So now if you do that, you can see here, here's the string sorted. So there's uppercase A somewheres, and then spaces, A, lowercase a, so they've sorted this whole string. You can sort it as long as you're not changing the string, as long as you're not changing the values inside of the tuple, you're fine. But as soon as you try to start changing it, then you're going to enter into errors. All right? I think that's pretty much all we had is by reference by value. Tuple, it's more fun to say than list. Tuple kind of rolls off the lips there. You can do a lot of things. You just can't append, insert, remove, or pop. The only way to change a tuple is to just reassign a whole new thing to it. And then style. I'm not going to go into style too much. Basically, if it looks messy, it is. Clean it up. If you looked in that one thing I had, I know when I started programming, we had a instructor that had us doing this all of the time. Put in this star next, or star in a statement here. We just used all kinds of stars there to separate our code, and helps a lot. And then obviously commenting is important too. But if it looks messy, it is. Just clean it up. I'll leave it at that. Hopefully this has been helpful for you. Hopefully you understand the list, how to do for statements with lists, how to do multiple for statements with lists, how to use tuples, and do some formatting. Have a great day and have fun with Chapter 4.